In this video, we're going to learn about stoichiometry. Alright, so the first thing to know about stoichiometry is that chemical reactions they're essentially like recipes. So, for example, if we have a recipe for a sandwich, it might say that we need 2 slices of bread, 3 slices of meat, and 2 slices of cheese, and together they're going to give you 1 sandwich. In the case of water, we can say that there are 2 molecules of hydrogen and 1 molecule of oxygen forming 2 molecules of water. The unit here is a molecule, and just like the unit above in the sandwich is a slice, notice how we don't say we're using 20 grams of bread and 15 grams of meat. We don't do that because, frankly, it's easier to just count them out. Just here's a slice, here's a slice. In the case of water, or just anything at the atomic level, you can't individually count atoms. And that's why we have the mole and molar mass to help us out. But ultimately, it's just a lot easier to work with if we know that we have 2 molecules of hydrogen and 1 molecule of oxygen giving 2 molecules of water. Just is a lot easier to work with than saying, for example, approximately 4 grams of hydrogen and approximately 32 grams of oxygen give you approximately 36 grams of water, which would be a true statement, it's just not nearly as easy to work with. So, let's consider this reaction. We have hydrogen and oxygen forming water. I could be asked the question, how many moles of water can be formed if 3 moles of oxygen react with excess hydrogen? I say excess hydrogen, that's just saying we have enough hydrogen. What's really determining the amount of water being formed is the oxygen. So what I can do here is say, okay, we've got excess. I will say we have excess hydrogen, and I know that we have 3 moles of H2O, or sorry, of O2, and I'm trying to get to X moles of H2O. This may seem pointless at this time. We will get to very complicated stoichiometric calculations, and believe me, this mapping is going to be very helpful to us. But I put the 3 moles underneath the oxygen because that's what I have. I know that I'm trying to get to moles of water, and I actually can do this in one step because the numbers, the coefficients that come out in front of each substance, they make the conversion factor. So for example, I can say that I have 3 moles of O2, and I'm going to multiply that by something over something to give us moles of H2O. Well, I'm going to be dividing by moles of O2 since that's not what I want as my unit, and I can cancel them. But on the top, I want moles of water, so I can put that there. And if I look here, the moles of water is just going to be this 2, and the moles of O2 is going to be the 1 that's kind of implied here. So I say 3 times 2 over 1 is 6, and there's my answer. Now, could I have solved this problem without the mapping? Yeah, probably. But let's see. If we change this to a problem where we're dealing with masses, then there's just a bit more going on here. So I think it would be good to use mapping, and you'll see how it works in a 3-step calculation right now. So if a chemical reaction produces 18.02 grams of water, what mass of hydrogen was used? Again, we're assuming an excess of oxygen, or that's really not what we're worried about right now. But I know that we have 18.02 grams of water, which I can actually put here. There are 18.02 grams of water. Now, I can't go directly from grams of one substance to grams of another because this conversion factor, the 2 and the 2, it's not grams, it's moles. So what I need to do is I need to convert my 18.02 grams of water to moles, and I can put a square around this, and then I'm going to go over here 2 moles of hydrogen. And this step is actually the same, really, as what we did in the previous problem. We had one step going from one to another, and I was trying to find this from what I knew. It's just that now I've got to get from grams to moles first, and then from moles to moles. And ultimately, we're asked for what mass of hydrogen was used, so I'm going to have to go up here to grams. Now, I'm going to do a bunch of dimensional analysis here, and I'm going to say that there's 18.02 grams of H2O as my starting material. I also know that since there are 3 lines, 3 arrows, there will be 3 conversion factors, which is nice. And then ultimately I'm getting grams of hydrogen, so I can fill this in here as well. But there's a little ways to go here. Now, something that I find helpful is filling in the conversion factors when I'm mapping. So for example, with the water, I need to go from grams to moles, I need a conversion factor, and what I do know is that water, well, if we have an oxygen, that's 16.00 grams per mole, hydrogen is 1.01 grams per mole, but there's 2 of them, so we've got 2.02, and we've got 16.00, so we have 18.02 grams per mole is our molar mass of water. I can do the same thing over here where I've got H2. I can say that there's 2 hydrogens times 1.01 grams per mole. So we have 2.02 grams per mole. Now, I really want to stress one thing. The 2 here, that coefficient out in front of water, has absolutely no bearing on the molar mass of water. If you were to take 2 hydrogens and 1 oxygen and add them together, you'll get about 18 grams per mole, which is what we did here. The 2 that I put in here was for the 2 hydrogens per water molecule, not because of the 2 out in front. That is not important for molar mass, and I've considered the same thing over here. 2 H2s would actually be 4 grams, but really, if we're talking about the molar mass of H2, just the 2 hydrogen atoms together, that's going to be 2.02 grams per mole. Where do these coefficients out in front, where do they come to play? Well, they're relevant here in that mole-mole conversion. So I'm actually, just to really stress this point, I'm going to underline the 2 here and the 2 here, and I'm going to say that we have a 2-to-2 ratio with the moles of hydrogen and the moles of water. It's just important to really stress that right now. So, as for, now that we have it mapped out, as for solving the problem, well, we have it all mapped out, right? We first are going to moles of water from our grams. So if I start with grams of water, I want to divide by grams of water in order to cancel out the units. And I'm going to moles of water. Wherever I'm going is going to be on top. Where I came from is on the bottom. So as I go to moles of H2, I'm going to put that on the top. And where I came from was moles of H2O. I'm going to put that on the bottom. And notice that they cancel out. And then we have grams of H2 over moles of H2 is what we'll have here. Grams of H2 over moles H2. These cancel. And notice, I cancel out a whole lot of units. The last unit standing is grams of hydrogen, which is exactly what we want right over here. So, of course, notice how I just put in a bunch of units. Here come the numbers. Well, I know that it's 18.02 grams per mole of water. So 1 mole is 18.02 grams. And I know that we have 2 moles of hydrogen for every 2 moles of water. so I put a 2 over 2, and I know that every mole of hydrogen, every 1 mole of hydrogen is 2.02 grams. And there we go. From here, it's a matter of just plugging it in. 18.02 times 1 over 18.02 times 2 over 2 times 2.02 over 1 is equal to 2.02 grams of hydrogen. Typically, you'll have something that requires a little bit more thought in calculation, but I figured I would make this one, in terms of the calculation, fairly simple, so that when you go to something harder, you'll at least have you'll have a good example to go from. I hope this has been helpful, and leave a comment. Thank you.